Okay, so this video is going to go over the answers to the first 3 warm-ups for chapter 1. So for this one, it wants us to give 2 other names for line AE. So let me go ahead and clarify here. This is A, this is C, and then it has arrows on the either end here. Notice the S over here does not have a point next to it, so that is actually naming the plane. So 2 other names for line AE. You could just write it in reverse, and you could also put the symbol of a line on top, or you could write out the word line and then put the 2 letters. Now, there's also another point on line AE. It's this C over here. So you could also call it AC with the picture of the line on top. You could also call it EC, and again, you could reverse these letters as well. Another name for plane S, whenever you name a plane, you need to name it with 3 non-collinear points. So I can't name plane S DEB because those 3 points are on the same line. So I would either need to write out the word plane and then pick 3 points that are not on the same line. So I could use D, E, and F. I could also use points D, B, and F, and then any combination or any order of any of these. So I could also say plane EBF, just as long as you don't name these 3, because it needs to be named with 3 non-collinear points. S is not a point, S is the name of the plane. Now the next one is to name 3 collinear points. So I could name point D, E, B, or A, E, C. And again, you could name it in any order. So if you'd rather do alphabetically, B, D, E, it doesn't really matter. And now the intersection of line AC and plane S. This line AC is going through the plane right here at point E. So you could just put capital E. If you write the word point in front, that's acceptable as well. So that was a review of 1.1, where we learned the different vocabulary and ways to name the different things that we're going to see in geometry. Then in 1.2, here again, I'm not going to ask you to measure anything, but you may be given something like number 1 on a standardized test, where they're going to give you the measuring device and then draw something next to it. However, a question like number 1 will not be on your test or quiz. The way that you use a measuring device like this, for example, a ruler, to understand what all of these little lines here represent, what you can do is count the gaps. So for example, in between like 0 and 1 here, notice there's 1, 2, 3, 4, 5, 6, 7, 8 spaces. So that tells me that each one of these little lines is 1/8. So this would be 1/8, 2/8, 3/8, and so on, all the way over here to 7/8. So notice over here, once we hit the 1 inch mark, then this would be 1/8, 2/8, and then it goes all the way up to 3/8. So that's why this segment AB is going to measure 1 3/8 of an inch. But again, you will not have something like that on your quiz or test. For the next one, it wants us to find the length of CE. So this is where I can use my segment addition postulate, and I know that I can add the little piece of CD to the other little piece of DE and get the length of the whole segment. So all I have to do here is do 7 plus 15, and it equals 22. My advice to you is on the quiz tomorrow, show what you're trying to add. Because if you make a careless mistake, I can at least give you partial credit that you understood that you were supposed to add 7 plus 15. But let's say when you added it, you got 21, at least I can give you a few points just by showing what you tried to do. Then for the next one, you'll have a question similar to this, where I'm gonna expect you to graph the 4 order pairs and then determine if those segments that are created by connecting the four order pairs together, if those segments are congruent. So for example, if I graph F and G, and it's going to tell you, is FG congruent to HJ? So when I graph F and G, I'm going to graph them and then I'm going to connect them to make a segment. It doesn't have any numbers here, but I can start numbering. So this would be -1 here, and then I need to go 1, 2, 3. So over to -3, and then up to 1, 2, 3, 4, 5. So -3, +5 is there, and I'm going to label that as F. And then for G, +2, and then up to 5. And that would be the segment for FG. Now remember, when it's horizontal like this, you can just count the little squares. So this has a length of 1, 2, 3, 4, 5. So FG has a length of 5. And then, or you could have also subtracted. You get rid of the part of the order pair that's the same. And then what you would have done is -3 minus 2, but then you have to absolute value it. And that's how you can still get the +5. Then for HJ, H is 3, +1. And then J is +3, -3. And then I'll connect the points. So +3, -3 is right here. And then I will count the little boxes, 1, 2, 3, 4. Or again, you could subtract and do 1 minus -3, which would give you 1 plus 3, which gives you 4. Same answer I got when I just counted the little squares. So HJ is 4. So because FG is 5 and HJ is 4, and these are not equal, I would say that they are not congruent. And you can either write out the word or put the symbol. For the next one, it wants us to find the length of KL. So if it is graphed on a number line for you like this, you could count the little gaps and figure out how long it is. So 1, 2, 3, 4, 5, 6, 7. So KL has a length of 7. Again, you could also take the coordinates. So K is -3, L is 4. So what you could do is subtract them, -3 minus 4, or you could do the bigger coordinate minus the smaller. Either way, you're going to get the same answer because you're going to find the absolute value. So the length of KL is 7. So for 1-3, it's telling us that segment AB bisects segment CD at E. Notice a picture is not provided. So I'm going to give myself a little visual, and I'll go ahead and draw CD here. And then I'm going to draw in AB, which is bisecting it. And it's a segment. And it says it's bisecting it at point E. It's giving me the length of CE here, and it tells me that it's 2 1/4 of an inch. It wants me to find the length of the entire segment CD. So remember, when something has been bisected, I know that it makes 2 congruent or 2 equal pieces. So then this tells me that ED here is also going to be 2 1/4. So in order to find the length of CD, I can either take 2 1/4, times it by 2, or I can also add 2 1/4 plus 2 1/4. Remember, when you multiply mixed numbers, you need to make them improper. So 2 1/4 becomes 9/4. And then I can turn a whole number into a fraction by adding a 1 to the denominator. I'm going to simplify before I multiply. and this gives me 9 over 2, which equals 4.5. Now, if you would have preferred to just add the fractions, you can add the two whole numbers, 2 plus 2, 4, and then 1 plus 1, 2 over 4, which simplifies to 4.5. So the length of CD is going to be 4.5 inches. So you could do it either way. For the next one, they're telling us that point M is the midpoint of XY, and XY got erased here. So this is XY, and this is your midpoint. Remember, when you're given that something is a midpoint, that splits your segment into two congruent pieces. So I know that XM is going to be equal to MY. So in order to find the length of XM, I need to first find the value of X. So I'm going to set 2X plus 7 equal to 8X minus 23. Again, it's really important that you're showing that you understand the concept of what a midpoint means. And so essentially what it was is XM is equal to MY, and that's what I set up here. And now I need to solve for X. You can choose to move your variables to the left or the right. It doesn't matter. I'm going to go ahead and subtract the 2X. You could have also subtracted the 8X. Either way, then you get 7 equals 6X minus 23. I'm going to add the 23 to both sides. And now I'm going to go ahead and write the answer up here. So 7 plus 23 is 30, is equal to 6X. Divide both sides by 6, and X equals 5. Now the question didn't say find X. It wants me to find the length of XM. Remember, XM is this expression 2X plus 7. So I'm now going to take the 2X plus 7. I'm going to replace my newly found value of X, and then I'll follow order of operations. 2 times 5 is 10, plus 7, and the length of XM will be 17. Then number 3 says point M is the midpoint of PQ, and they gave me the two endpoints. It wants me to find the coordinates of M, which is the midpoint. Remember, the formula is x1 plus x2 divided by 2. This gives you the x of your midpoint. Then you'll find the average of the y's, and that'll give you the y of the midpoint. So I'm going to go ahead and label my two endpoints. This one I'll say is my x1, y1, order pair number 1, and endpoint Q will be my x2, y2. Again, it doesn't matter which one is which. Just stay consistent. So now I'm going to plug them in. So 2 plus negative 8 divide by 2 equals negative 6 divide by 2. So the x of my midpoint is negative 3. For the next one, my y1 is negative 6. I'm going to add that to the y2, which is 0. Divide by 2. And again, remember, it's giving you the y of the midpoint. So I end up with negative 6 over 2, which gives me negative 3, which is the y of my midpoint. So now I'm going to take both of these answers and put them into an ordered pair. So the final answer here for the midpoint, point M, negative 3, negative 3. Also be able to work backwards of that formula where you're given the midpoint and one endpoint. So this is going to be my XM and my YM. This is my midpoint. And then over here, this endpoint will be my X1, Y1. I am trying to find the coordinates of the other endpoint, which are going to be my X2, Y2. That's going to be H. So I'm going to go ahead and plug it into the formula. So the first thing I'm going to do is write down x1 plus x2 divide by 2 equals the x of the midpoint. So let me go ahead and replace. So I'm going to take the x1, which is 5, And I'm also pulling out the x of the midpoint. And what I'm solving for is this x2. So let's replace it. So I have 5 plus x sub 2, which is just a little label, divided by 2 is equal to 4. Here's where your algebra skills come into play. First thing I need to do is clear the fraction. So I'm going to multiply both sides by 2. And now I'm left with 5 plus x sub 2 equals 8. Subtract 5. And the x of my endpoint, h, so point h, so far I found the x of that order pair. Now I need to find the y, and I'm going to use the y1 plus y2 divide by 2 equals the y of the midpoint. So here I can go ahead and take the y1, which is going to be 3. Go ahead and put that there. I don't know y2, so I'll go ahead and leave that as a variable. Divide by 2 is there. And then I'm going to grab the y of the midpoint, which is going to be the -1. I'm going to solve this algebraically by multiplying both sides by 2. 3 plus the y sub 2 equals -2. Subtract the 3. And the y of that endpoint is -5. So the answer to this question is a coordinate. So it's the order pair +3, -5. Be able to do this tomorrow. Now, as far as the distance question tomorrow goes, it's not going to be a word problem. I'm just going to give you 2 order pairs and ask you to calculate the distance between them. So here it is a word problem. It's a paragraph. Don't panic when you start to see word problems in this course. Chances are the question's pretty simple. So really all we're doing here is finding the distance from the swing, this order pair, to the sandbox. So all I have to do, and I'm going to leave it in simplest radical form, I'm going to take my first order pair, the 7, 2, and then the second one, -3, 8. This is going to be my x1, y1. This will be my x2, y2, and I'm going to plug it into the formula. Remember, the formula is x sub 2 minus x sub 1. Again, it's just little labels. Then subtract the y's, square them, and it's under a radical. So let's go ahead and fill it in. So I take both of the x's, this one and this one, and I'm subtracting them. So -3 minus 7 squared. And then now I'll grab the y's, the 8 and the 2, subtract them, 8 minus 2 squared, and this is all still under a square root symbol. This is going to give me -10 squared. This is going to give me 6 squared. 100 plus 36. I'm going to add them. And now I need to do a factor tree because I want to leave this in simplest radical form. So this 136, I can either start with 2 times something. I'm going to do 4 times 34. That'll give me 136. And then I'm going to keep breaking it down till it's prime. And then I look for pairs. I have a pair of 2's. That's a perfect square. It comes out. These 2 guys that don't have any pairs, multiply them back. So the final answer here in simplest radical form will be 2 times the square root of 34. My advice to you tomorrow, show all of this work of how you plugged it in. If you get to this point and you blank out and forget how to simplify, at least you'll get some points for showing the work. If all you do is put like the square root of 135 and there's no work to back it up, you just lost everything. So it's very, very important that you show work.